Hey everybody, Trey here. Welcome back to another video. Apologies for my voice in this video. I ended my Storm Chase tour season just a few days ago, but at the same time picked up a little bit of a cold, so still battling that. But I thought doing a video on today's setup across the Northeast was warranted. Quite an unusual setup for this portion of the country. We have a level 3 out of 5 enhanced risk in the orange shaded region here, so parts of far southwest Maine, much of Vermont and New Hampshire, far eastern New York, into parts of Massachusetts there in the greatest severe weather threat for today. Level 2 out of 5 slight risk surrounds that large yellow shaded region here all the way down into the Ohio River Valley region, parts of Kentucky, Ohio, West Virginia, and areas off to the north, with a marginal risk surrounding that. So quite an unusual look here for parts of the Northeast to have such an elevated severe risk, but that is what we have on the table for today. All severe hazards are on the table, including tornadoes. Tornado threat is quite elevated, especially for this portion of the country. 10% region there in the yellow shaded region there within the enhanced risk, with a 5% surrounding that from the Canadian border southward into parts of Connecticut, eastern New York, over toward the Boston and Portland, Maine areas. Large 2% extends down into the Ohio River Valley region. So tornado threat is certainly elevated with today's setup, as is the damaging wind threat. In the red shaded region here, a 30% risk for damaging winds surrounded by a large 15% risk. So damaging winds do look to be a threat today with these storms. Large hail, may see a few instances of isolated severe hail, but large hail should not be the greatest threat with today's severe storms, but we could see again a few instances of larger hail with these supercells today. But the greatest threat certainly damaging wind and tornadoes with this setup. So without further ado, let's go ahead and get started. Let's first take a look at what's going on as we speak, recording this just before 9:30 a.m. Central Daylight Time here in Norman. Some shower and thunderstorm activity moving quickly off to the east through parts of New Hampshire into Maine. That should quickly move off to the east this morning. We do have a little bit of a band of showers behind that coming in, but it looks fairly narrow. It doesn't look very convective in nature, so not too much in the way of morning activity here that might ruin the setup for later on. If we look at our visible satellite, we do see quite a bit of cloud cover across the region here. Just for some context, here is New York, here is Maine, up in here, Vermont, New Hampshire, right in there. So quite a bit of clearing at this point across the eastern half of New York, moving into Vermont right now, but still quite a bit of cloud cover across the region. Here's that little band of showers moving in from the west, but quite a bit of clearing behind that. So shouldn't be too much of an issue in getting the atmosphere to destabilize fully. Should have quite a few breaks in the clouds for later on to allow that atmosphere to destabilize fully across this region. You can see the very well-defined swirl here in the cloud pattern across that Great Lakes region. That is going to be our surface low moving off to the east quickly today and will be a main factor in today's severe threat across the Northeast. Moving on to our upper air maps here on the SPC mesoanalysis page, not a whole lot going on across the country at the moment. Very quiescent flow across the southern tier of the U.S., 5 to 10 knots of 500 millibar flow, as you see here across the southern half of the country. Here off to the north, though, our jet stream is located off to the north here, and we see a couple different little waves within that main stream there. One across the Pacific Northwest, and one here across the Great Lakes region into the northeast. This is going to be our main sort of long wave trough impacting today's severe weather setup. You can see a couple little short waves rotating through this broader trough here. Here's one right across kind of the Michigan region down into Ohio. In Kentucky, a little bit of a kink in the height contours there. That will move off to the east slowly today. And there's one back here as well. A little bit of a jet streak associated with this secondary shortwave across the Dakotas into Minnesota. A little bit of a 60-knot jet streak there. That is a secondary shortwave expected to rotate through. I suspect this one here across the Great Lakes region will be our main shortwave for today's event. Given that it is already pretty close to our area of interest, I would suspect that the timing of this shortwave may be a little bit earlier than is normally anticipated. So we may see storms start to fire sometime around maybe 19 to 20 Z across this region, probably eastern New York first, up into far eastern Canada, and then spreading into parts of Vermont, New Hampshire, and Maryland, Massachusetts, and the rest of the Northeast with time. So also all going to depend on moisture return. Moisture return is going to be key today. And that will be fueled by this surface low. Very strong surface low here, wound up surface low across the eastern Great Lakes region, center there, right off to the northeast of the Michigan region. Cold front, you can see draped down to the south, a little bit of a pressure tongue there, as well as a wind shift. So our cold front looks to be somewhere in there. Warm front off to the north in Canada. So a very well-defined, wrapped-up surface cyclone here with a broad warm sector. You can see a lot of real estate here within the warm sector of this cyclone. Also, you see a little bit of a surface trough. If I were to erase this arrow here, you see a little bit of a surface trough well ahead of the actual cold front. So this is a little bit of a prefrontal trough. We'll have to watch that as a possible initiating boundary for severe storms in today's setup. We should have multiple initiation mechanisms in this setup. Initially, the warm front and the prefrontal trough will be our main initiation mechanisms, and then a separate area of severe storms is likely to develop along the cold front as it moves off to the east. That's why the severe weather outlook for today does kind of extend down in a narrow tongue down into the Ohio River Valley region. That is for any storms along the cold front later on. Surface low should continue to intensify as the shortwave aloft moves in. Now, just from these couple of maps here, you should be able to kind of see why this might be a favorable setup for discrete storms. Somewhat of a subtle shortwave here, not one of these high amplitude, deep digging troughs we often see in the spring and early summer, but it is just one of these low amplitude features rotating through the main flow. So that always raises my eyebrows as far as a more discrete storm mode. Much more subtle forcing, not a lot of forcing for a pure squall line here. Plus, with the prefrontal trough, we've talked about this with a lot of southeast events. These prefrontal troughs are very subtle themselves and can have much more subtle forcing along them. So assuming this is going to be our initiating boundary later on, this prefrontal trough, oriented much more north-south and having subtle forcing as is, with our winds aloft more out of the west, that tends to be a favorable orientation with our shear vectors with respect to the initiating boundary. We'll talk about that a little bit more in a second as we go through some model data, but right away, starting to see some signs that a more discrete storm mode is favored in today's setup. Going through some of the other layers here from 500 millibars, you see that shortwave. Let's take a look at 700 millibars to see how that shortwave is oriented. And you can see it's a little bit different. Our main shortwave, can't really see anything with this lead shortwave, but back here with our secondary shortwave and that little jet max back there, you do see that shortwave very well defined back there across kind of the central to western Great Lakes region into the Midwest. Again, not much here with this lead shortwave. We do have a little bit of enhanced flow here at 700 millibars associated with this lead shortwave, so that may be some semblance, some manifestation of that in the that lead shortwave in the 700 millibar flow here. 850 millibars should have some semblance of a low-level jet given the strong low-level cyclogenesis that has occurred, and that is what we see here. Strong low-level cyclone located here just off the Michigan coast there, the northeast Michigan coast, with a plume of strong low-level winds here, 35, 40, 45 knots. Should maintain itself through the day as that shortwave aloft moves in and allows that low-level cyclone to intensify somewhat. So we should keep the low-level jet fairly strong throughout the day, allowing for that low-level shear to maintain a pretty strong nature going into the afternoon with this setup. Now notice how the 850 millibar winds are out of the southwest, so they are veered a little bit, and we talked about a lot of times in the plains how that can be problematic, as the southwesterly low-level flow can actually bring drier air in from the west into the low levels, kind of creating a blow-drying effect, leading to a less favorable environment for severe storms. Well, that's not going to be the case today. If we look at our other 850 millibar map here, you'll notice that even though we have southwesterly low-level winds here, the green contours are our higher dew points, and you can see we have a large plume of low-level moisture located out here to the southwest of the region that is under the gun today. So even though we have southwesterly low-level flow and it's kind of veered, shouldn't be too much of an issue, especially with surface flow that is out of the south. That should lead to strong veering and strengthening of the winds with height, leading to strong low-level shear, and the ability for this low-level jet to still pump in a lot of moisture to this region. Moving on to our raw surface data here, you can see that we do need a little bit of work to occur to get the best moisture up into our area of interest for today's setup. Only 50s and 60s dew points across this region right now, but that best moisture is not all that far away. 70s dew points all the way up into Connecticut, eastern New York, Pennsylvania at the moment. So not going to take a whole lot to get the best moisture up into this region with southerly low-level flow already in place across this region ahead of the surface low. But very juicy air mass down to the southwest, advecting into this region. Temperatures already in the 80s across central New York with dew points in the low 70s. Same thing down to the south in Pennsylvania. So a very juicy, moist air mass making its way off to the north and northeast into parts of Vermont, New Hampshire, Maine, Massachusetts for today's setup. Here's our morning observed sounding at Albany, New York, far eastern part of the state. Already a pretty impressive sounding for this early in an event. This was taken at 8 a.m. Eastern Daylight Time. Already a little bit of elevated instability here. You can see on the sounding, about 400 joules per kilogram mixed layer CAPE. Certainly elevated above this little warm nose in the low levels. Going to take some time to work out those low-level thermodynamic issues, but we should see that instability gradually grow throughout the day through a combination of strong low-level warm advection, surface heating, as well as the approach of the shortwave trough to help cool that little inversion there aloft. Kinematically, however, very impressive kinematics for this early in the event, and they should maintain themselves as we talked about going into the afternoon of today's setup. Very strong turning and strengthening of the winds as we go up in the lowest kilometer or so of the atmosphere, starting off with about 10-knot south-southeasterly surface winds veering to almost due westerly winds there at 850 millibars, 35 to 40 knots or so. So very impressive veering of those winds with height, and those winds certainly do strengthen as you go up in that lowest kilometer or so of the atmosphere. So very strong low-level shear at this point in the morning. Again, that is expected to maintain itself going into the afternoon, as that low-level jet is expected to hang around with the approach of the shortwave trough aloft and the surface low, the low-level cyclone maintaining itself across this region and not making too much of eastward progress throughout the day. Very impressive-looking low-level photographs here. That classic sickle-shaped photograph, they're already in place today. A little bit of weakness in the mid-levels of the photograph. Anything really above 2 kilometers, very unidirectional flow as you go up here through the atmosphere, and not a ton of strengthening in that flow as you go up. You can see here the winds about a kilometer off the surface, about 35 knots or so out of the west-southwest, and we maintain that west-southwesterly flow all the way up through about 300 millibars or so before you get a little bit of a northerly component to the flow. And you can see those 300 millibar winds about 40 knots as well. So not a ton of deep layer shear above about a kilometer. All of your strongest shear is relegated to the lowest kilometer or so of the profile with not much action aloft. We should see some improvement of that, I would suspect, as we get a little bit of strengthening of the flow associated with the shortwave coming in today. So we should see a little bit of strengthening in the mid to upper level flow, but overall fairly unidirectional profile above a very strongly sheared low level environment. Given such strong low-level shear and strengthening instability with time, we should see a supercell mode take over. The saving grace here, usually in these unidirectional flow setups, you don't see this much turning in the low-level wind profile, and that tends to lead to more of a linearly organized type of setup. Not the case today, since we have such strong low-level shear. Supercell still should be the main setup, but this weaker mid and upper-level shear may lead to a more high precipitation storm mode and a little bit of difficulty in viewing any mesocyclones within these supercells, but still plenty of low-level shear and strengthening instability with time should foster a supercell, mostly a supercell mode, perhaps some line segments in there, especially closer to the warm front, could be a little bit grungier up there, but out along that prefrontal trough, we should see these supercells, supercells be the main convective mode with today's action. All right, let's take a look at a little bit of model data here. This is our morning NAM run, 12Z NAM. 500 millibars we'll start off with. Here is that big long wave trough here across the northeast quadrant of the country. Here is that short wave centered across Michigan down into Indiana, Ohio at this point. Again, going to move off to the east slowly today and should start taking aim at the northeast by probably early afternoon or so. This is at 18Z, so 2 p.m. Eastern. You can see that the shortwave is already starting to impinge upon eastern New York into Vermont and New Hampshire. So we probably, again, will start to see storms fire a little bit earlier in this setup, probably sometime around, 1, 2, 3 p.m. Eastern or so. First across parts of eastern New York, and then quickly move off to the east into Vermont, New Hampshire, Massachusetts. Going on into the evening hours, 21Z, 0Z, we're kind of in between the two shortwaves now. So again, it's a very subtle shortwave, not one of these deep digging troughs. So somewhat subtle forcing associated with this particular shortwave. So we're not going to see a ton of storms develop here. Going to be fairly subtle forcing both on the large scale and on the mesoscale. So again, supercell should be the favored mode. A fairly discrete supercell should be the mode with this setup. Could see a few sort of clustered line segment type things, especially along the warm front where your shear vectors are kind of along the warm front there, but still we should see mostly in the open warm sector along that prefrontal trough, we should see a fairly discrete supercell mode maintain. Going down to the surface, we see our well-defined surface low here just off the northeast coast of Michigan. Again, not a ton of eastward motion expected with this surface low. I'm going to zoom into our northeast sector here. so we can get a little bit of a better picture. So here's the center of our surface low, just off the northeast coast of Michigan. Very expansive surface low here with that cold front draped down to the south. Here is that prefrontal trough at 12Z. Very well-defined prefrontal trough there. Not a ton of eastward motion with it as well. Here we go into the early afternoon, 2 p.m. Eastern Daylight Time, and that prefrontal trough very well-defined here across eastern New York. So this should be our main initiating boundary in the open warm sector. And again, oriented fairly north-south here. Warm front located up into eastern Canada, so not going to be a U.S. threat per se with that. Any warm frontal convection could see some. If the surface low does take a little bit more of a southern track, could be start to impinge upon parts of far northern New York, Vermont, New Hampshire. But mostly the warm front should maintain a position there across eastern Canada into probably northern Maine. And we're probably not going to see enough robust ingredients get up to that point of northern Maine to see a robust severe threat up there. But our prefrontal trough, very well-defined prefrontal trough there. Again, very much north-south oriented. If we were to put in our shear vectors here, you can see that we have a very perpendicular shear vector with respect to that initiating boundary. So given the subtle forcing along the prefrontal trough, the subtle forcing from the very low amplitude shortwave aloft, and the very favorable orientation of the shear vectors with respect to this prefrontal trough, I think discrete supercells are a pretty good likelihood with any convection that develops in the open warm sector. Cold front still well back in here as well. So cold front is not going to be anywhere close to this prefrontal trough. Cold front still well back in here, it looks like, through that little pressure tongue there. So we have plenty of real estate for the storms to fire along the prefrontal trough, and then a second round should develop along the cold front later on. That should be a little bit more of a tendency to form into line segments there with our shear vectors a little bit more parallel to that cold front, but with the prefrontal trough, discrete supercell should be the favored mode, firing up as early as probably early afternoon, 1, 2, 3 p.m. as the shortwave starts to impart its influence on the region, and we get that moisture up into these areas. Speaking of moisture, let's go back here to our moisture. So you can see we start the morning as we are right now, not really favorable moisture across the area of interest for today's setup, but our 70s dew points not that far off here. The purples are your 70s dew points. They quickly make their way off to the north on that southerly low-level flow. This is at 18Z. So again, 2 p.m. Eastern, and we're still trying to destabilize this atmosphere here. Parts of eastern New York, though, well within that 70s dew point plume, western Vermont, Massachusetts, Connecticut. So we should see, again, we have favorable moisture here with favorable forcing overspreading this region. Should see storms fire fairly early with this setup. And then as the moisture spreads off to the east and northeast, we should see the severe threat spread off to the east as well. Those 70s dew points start to surge into southwest Maine there by late afternoon, 21 to 0Z, 5 to 8 p.m. this evening. Plenty of moisture across this corridor with 70s dew points there. So all in all, a very juicy air mass going to be in place fairly early on. As the moisture advects off to the northeast, that severe threat will advect off to the northeast as well. So we'll take some soundings here across this region. How about eastern New York to start off with? The Albany area at 18Z. And then we will go forward with time to 21Z. We'll start to go into probably, southern Vermont. And then we'll go kind of off to 0Z over into New Hampshire, southwest Maine. So the progression of sounding across the region, already favorable looking profiles here by early afternoon. This is a very similar look to what our morning sounding showed at Albany. So not a ton of change needed to modify this sounding for severe convection, but we will see destabilization happen pretty favorably through the early afternoon hours to get here on the NAM about 2,000 joules per kilogram mixed layer CAPE, 82 over 73 at the surface. So again, a very juicy low-level air mass here to work with. Not, at first glance, not maybe the most favorable skew T you'd see for significant severe weather. We've seen a lot of soundings this year with very steep lapse rates aloft. We see here as we go up in the profile, your red profile here, your temperature profile is a little bit more vertical, a little bit more straight up and down than a lot of soundings we've seen with past events this year, where your red profile kind of goes like this, so very steep lapse rates aloft, creating lots of fat instability, if you will. Here, that's not going to be the case so much. Our mid-level lapse rates are on the weaker side here, which may be a negating factor with this setup. I don't think it's going to be too much of an issue since we have such strong kinematics at play. We'll have strong surface heating in those cloud breaks. So I don't think it's going to be too much of an issue, but it is something to keep in mind that the lapse rates aloft, not the most favorable for significant severe weather. You can see our 3 to 6 kilometer lapse rate here is sub 6 degrees Celsius per kilometer, 5.9 degrees Celsius per kilometer. So that 3 to 6 kilometer layer here goes from about here, about 700 millibars, to about 500 millibars, is under 6 degrees Celsius per kilometer. A little bit of a warm nose, slight warm nose in there as well. So not the most favorable mid-level lapse rate plume for really robust updrafts, but still plenty of instability, 2,000 joules per kilogram mixed layer CAPE, with fairly strong low-level lapse rates, 0 to 3 kilometer lapse rates in excess of 7 degrees Celsius per kilometer. There you see that steep lapse rate layer above about 900 millibars or so. So I don't think it's going to be too much of an issue. Again, this is just a model projection, so if we get a few degrees Celsius per kilometer, or a few tenths of a degree Celsius per kilometer greater than what is forecast here, we shouldn't have a problem at all, even with hovering right around 6 or just below 6 degrees Celsius per kilometer mid-level lapse rates. I don't think it's going to be too much of an issue, but we will need to keep an eye on that, as that could negate some of the intensity of these updrafts in this setup. But just keep that in mind for those of you going out chasing today, that we may see these updrafts perhaps struggle a little bit going into the afternoon because of that mid-level lapse rate issue. Kinematically, still very favorable. That strong low-level shear there, southerly low-level winds at about 10 knots, strengthening to about 40 knots out of the southwest at 850 millibars. Very strong low-level shear in this setup. Effective storm relative helicity about a 250 meters squared per second squared. Strong, nice sickle-shaped hodograph there. So certainly a kinematic profile favorable for tornadic activity, assuming supercells can mature and sustain themselves, which shouldn't be too much of an issue here in this environment. We still have plenty of instability despite weaker mid-level lapse rates. Decent instability, strong low-level shear certainly favors tornadoes with any sustained supercell in this setup. Again, weaker mid and upper level shear here, very unidirectional profile, not a ton of increase in the winds as you go up in the atmosphere. So we still have plenty of deep layer shear for supercells, but above that kilometer, that 0 to 1 kilometer layer, very unidirectional flow, fairly weak mid and upper level shear could create a more high precipitation mode with those supercells. 21Z, here we go to 4 p.m. Not, again, your thermodynamic profile here, not the most favorable for significant severe weather. Kind of a saturated profile here. Still enough instability, just looking at the numbers here, 1,500 joules per kilogram mixed layer CAPE. But your lapse rates are pretty weak here. You see those lapse rates, lots of green here in this lapse rate profile down on the bottom left corner of the sounding. Not a ton of steep lapse rates aloft there. 0 to 3 kilometer lapse rate still above 6 degrees Celsius per kilometer there, so no issues there. But as you go farther up into the atmosphere, fairly weak thermodynamics there with limited lapse rates aloft. So that may, again, temper the intensity of these updrafts, but I don't think it's going to be too much of an issue today. We should see storms maintain themselves and become strong regardless. Wind profiles maintain a very favorable component for tornadic activity here. Again, still that problem with fairly weak mid and upper level shear, but your low level shear fairly strong. We do start to see winds veer a little bit with time at the surface in the low levels there, much more southwesterly flow now. This is at 5 p.m. Eastern Daylight Time here, again, southern Vermont. But we still have nice curvature there in the low levels of the hodograph. Strong speed shear in the low levels of the hodograph should still favor a tornado threat with any more sustained discrete supercells there. But we do start to see those low-level winds veer with time. Southwest Maine into New Hampshire by 0Z, 8 p.m. Central Daylight Time. Any sustained supercells will certainly have a tornado threat in this environment. Very strong veering and strengthening of the winds with height here. But look, most of your hodograph is that low-level profile there. You have that strong curvature there, strong veering and strengthening of the winds with height. Should favor that a sustained tornado threat, perhaps an isolated strong tornado or two. If a mature supercell can sustain itself, that may be tempered a little bit by this lapse rate issue here. And this is a little bit of a concern here. We do see those low-level lapse rates come down a little bit, sub 6 degrees Celsius per kilometer, a little bit of a tiny warm nose there, right about 850 millibars. So somewhat weaker low-level lapse rates there may temper things a little bit, but still, I think we have enough instability and enough lapse rates here in the low to mid levels to sustain robust supercells. And in this environment, with any robust supercell, we'll have the threat of producing multiple tornadoes, perhaps an isolated strong tornado here with such strong low-level shear as that low-level jet maintains itself through the day. So let's go to some convection allowing model data here. This is the 12Z HRRR run. So there's your morning convection making its way off to the east pretty quickly. Not too much of an issue there. And we see storms start to fire there. 17, 18Z start to get some robust activity closer to the warm front there. Southern Canada, northern New York. A little bit more of a clustered mode up there as we talked about. And then we start to see by early afternoon a little bit more discrete activity across the Vermont, New Hampshire corridor. Some more discrete supercells down here with southern extent along that prefrontal trough. Moving into southwest Maine, and then we get some trailing activity perhaps along the cold front down into the Ohio River Valley region. So pretty nice looking. You don't see a ton of activity up here, again, because we have more subtle forcing, except kind of along the warm front there, a little bit more of a clustered mode with southern extent, a little bit more discrete supercells will favor here in this particular model run, and they maintain themselves for quite a while going into southwest Maine and eventually into the Atlantic. Let's take a look at our latest HRRR here, 14Z HRRR, coming in hot off the press. So this is the latest model run of the HRRR. Once again, more clustered activity to the north, more discrete supercell activity across Vermont and New Hampshire to the south. Should have, again, that tornado threat as they move off to the east, and then some trailing activity along the cold front down into New York and areas of the Ohio River Valley down to the south going into the early evening hours. How about the WRF ARW model? So here's the WRF ARW. We do see here one of the things that we see among these first few model runs is that we don't see a ton of strong updraft helicity streaks, and I think that may have to do with the weaker lapse rates aloft. These models kind of are struggling with perhaps the intensity of these storms becoming really, really robust. If we were to see really robust supercells, we'd probably have much stronger updraft helicity streaks. We did see some in those HRRR runs there. This particular model not showing a ton of that updraft helicity streak action. And that could be a little bit, that could have to do a little bit with the weaker lapse rates aloft, kind of holding back the intensity of these modeled storms. We do see a little bit of updraft helicity in there, which is where the HRRR was showing it. It's kind of southern Vermont to southern New Hampshire, southwest Maine. So that should be our favored corridor for more robust storms. But those lapse rates aloft could be the main limiting factor with the robustness of the storms in today's setup. NSSL WRF. Overall, among the models, though, looks like a pretty similar idea. We do see kind of discrete activity, semi-discrete activity down here across this area by about 17, 18, 19Z, 1, 2, 3 p.m. or so. Kind of a quote-unquote string of pearls there. Not a ton of updraft helicity streaks there. There's a little bit of one there in southwest Maine. So that tornado threat would be strongest with those storms. And then some trailing activity along the cold front as well. So the models are pretty much locked in on a solution here. More isolated, discrete activity across Vermont, New Hampshire, into Massachusetts, southwest Maine with time. That will be where your greatest profiles are for tornadic activity, and then perhaps some activity down to this off to the west along the cold front as it comes in into the early evening hours tonight. So that's going to do it for this setup. Once again, a fairly unique setup for this portion of the country. Once again, an enhanced risk level 3 out of 5 for far eastern New York, Vermont, New Hampshire, far southwest Maine, into parts of Massachusetts, with a large slight risk extending outside of that and down into the Ohio River Valley region. All hazards on the table for today. The greatest threats going to be strong winds and tornadoes. Tornado threat is at a 10%. Yellow shaded region there is a 10% tornado risk, so just to the east of Albany, south of Burlington, Vermont, so Concord, New Hampshire, under the gun for that greatest tornado risk today. And Boston, you are in the 5% risk, that brown shaded region here that extends outside of that yellow shaded region there. Boston, Portland, Maine, Burlington, Albany in that 5% risk. But the greatest threat should be across this corridor in the yellow shaded region here. So far eastern New York, Vermont, New Hampshire, far southwest Maine into Massachusetts. Favored area for both the discrete supercells and the best overlap of instability and strong low-level shear for that tornado threat to persist with any more persistent, robust supercells. Damaging winds also going to be a threat with those supercells. And given that we don't have the really strong lapse rates aloft and kind of more those temperature profiles on the soundings a little bit more up and down rather than slanted back to the left, the top left of the sounding, for just to kind of simplify it for you. That is why we're not seeing a huge hail threat today. Plus the strong low-level shear, that's not very favorable for a large hail threat. That, coupled with the somewhat weaker lapse rates aloft, could temper the robustness of the overall updrafts, and the large hail threat not going to be a big risk today. We could see a few instances of isolated large hail here with these supercells, but the main threat's going to be damaging wind and tornadoes with this setup. Could see an isolated strong tornado or two, especially with any more persistent discrete supercells in that Vermont, New Hampshire, southwest Maine, northern Massachusetts corridor. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.